learners, researchers who like to learn these techniques. It is a very critical part of any research where they involve in the research activities. Okay? So I will be speaking on the parametric methods, and I think you all are from the diverse disciplines of social sciences as well sciences. So I would like to tell you the things in that manners only, so that you can apply your research in that area. So let me share my PPT as well. So can we interact in between with the participants?
Yes, sir. Participants can raise their hands and I'll allow them to unmute themselves.
Oh, sure, sure. So that's great, and we will try to interact with all of you. And this is now you can see my PPT.
Yes, sir, we can.
Okay. So is that in slideshow mode?
Yeah, slide mode, sir.
Here. And you can see my second slide.
No, sir, we can see the first slide only.
Third.
No, sir, it's not moving, I guess.
Okay. Now you can see.
No, I can see the very first slide, the title one.
Okay, not any other.
No.
Even now only.
Sir, the very first slide only we are able to see. So if we can stop sharing and reshare it again, let's try that way.
Okay.
Yes, sir, we can see your first slide.
Now second.
No, sir.
So it means it's not working on slideshow mode. So you can.
Yes, sir.
Let me give me just hello.
Yes, sir.
Let me reshare this one.
Okay.
So basically, I'm trying to share full screen if it is possible. Otherwise, I can start with that only. Now you can see second slide.
I said we can see the in a PPT outline, not with a slide share.
So I'm not able to share because I'm trying, but it's stuck there. So should I go with
Oh,
that only? I can use
yeah, we
this
can
view.
go ahead with this. At least this is visible, sir. Yeah, yeah.
Yeah,
Even if you zoom it out, that's better.
right, right. So we can go ahead with this manner. Okay.
Yes, sir.
So today I will be discussing on the parametric method, and it is a very important part of statistical analysis. So once you will have a lot of the data from the from any survey or from any experiment, then you will be having the first analysis with your continuous data. So I would like to go back to the your first sessions, which was taken by the professor. So variables. So what do you understand by the variable and the data? So here I will be going back to that one. So what do you understand by the data and types of the data? So you know that you will be having the nominal, ordinal, and interval and ratio data. So you already gone through this lectures, and I'm expecting that you clearly identify that which data is discrete data and which data is your continuous data. Okay, so I will be focusing here. It means that we are focusing on the continuous data, although we can go for the other than that as well. So here, if you will have the continuous data, it means that you will having the interval and the ratio data. So interval and ratio data, for an example, you will be finding the age of the participants in numbers, and what is your hemoglobin level, what is your blood pressure value, what is your uh, diabetic value. So these are the an example. So how much you are earning per day. Okay, so that is the examples of the your continuous data, and I will be focusing on then what is this one. Okay, so I will be trying to explain you the all the categories of the t-test. So in the t-test I would like to discuss with the one sample t-test, two sample t-test, which is also called as the independent t-test, and then after pair t-test and one way analysis of variance, and if it is time permit, then I will go for the non-parametric methods. So so far you already know that a lot of the statistical method is required if we want to publish our paper in a very good journal. So yesterday I was discussing with the one of the professor of the from the AIMS, and he asked me to contribute in for the statistical part. So he's asking that how to use betterly for the regression analysis. So once you will go in depth, he already did that regression part, but the reviewer wants that he needs more statistics. So you need to have good statistical knowledge, or if you not, then you can just collaborate with some statisticians. And I think I am also working with the Indiana University USA, and they are also working on the same things, that is the parametric methods and the survival analysis. So I will be just quoting these two things, because the people are just wants that how we can prove this one. As you are observing that in the field or in the survey, that this is happening in your data, this is happening in the field, then how you can prove those things with the help of the statistical analysis. Let's begin with the what is a parametric method. So I think you all know that what is the parametric. So parametric is nothing but it's follow the sum of the assumptions for a t-test or maybe a pair t-test and analysis of variance. You in statistics, while you are going for the testing of the hypothesis, then you need to follow the sum of the assumption for everything. Okay, so if you will go for the regression, then you will just test some assumptions. If you will go for the parametric methods, means if you want to go for the t-test, then you need to you need to assume that it is following the sum of the assumption or not. So all those things needs to be tested, because in statistics you need to follow that your data is behaving like this or not. If it is not behaving in that manners, then you will find out the some other statistical techniques which can be applied in that one. Okay, so you always care for assumption of this statistics, and that is the part here we are discussing about the parametric method. So parametric methods are those methods which follow the two assumptions, majorly following the two assumptions, that is the your data is following a normal distributions. So normal distributions, for example, what do you understand by the normal distribution? I will take some cases as well, and then we will be discussing. So in layman, what do you understand by the normal distributions? In layman terms, what do you understand by the normal distribution? Can anyone tell me that what do you understand by the normal distribution? Anyone can raise their hands and then they can discuss. Yeah, please, Kavita.
You can unmute
Very good
yourself.
morning. Yeah, a very good morning. When we say that it is your data is distributed equally between your mean or average, giving a proper distribution, a dumbbell shape.
True,
So we
Kavita. So you saying that it's mean, median, or these values are closer, then you can say that it is the following their distributions. Why not? You people can also write in the chat box that whatever the is your views. I parallelly check this chat box on online platforms, so you can even that one. So I'm asking that how in a layman terms you know that. Well, many a times we always discuss in the family and in the office, in the classrooms. So is that normal class? We are asking that, is that normal class, or it's very hi-fi class, or it's very poor content of the class? So we always talk about. So so basically that is the your normal distribution. So whenever we talk about that, this the level of this class is very high, it's going beyond of the overall students. Or if it is, we will saying that the content of the class is very poor in the classes. So that's, we will be saying it's very this one. And we will say that the class content and the delivering is very normal. Okay, so normal, you know that in layman terms. Similarly, you can also understand the normal distribution in daily life as well, in the statistics as well. Okay, so here we will talk about the what is the normal distribution. So normal distribution is, let's say if maximum people are saying that what is your how much you spend per day on your pocket. Okay, so what is your everyday spends. Okay, so somebody is saying that, let's say I'm asking all of you that how much you spending every day. So you spend some money. Okay, so for an example, you spend 2000, somebody spend the 1200, 1400, like that. So maximum number of the participant is spending that amount. If it is that amount is very closer to each others, that means that this is follow a normal distributions. Okay, in that is the understanding of the normal distribution in layman terms. Okay, so maximum value is coming in a in a same manners. Okay, so this is the normal distribution. Now we will talk about the technically what is, you can understand the normal distribution. So it is a symmetrical distribution. So whenever we will draw this normal distribution, so it is the symmetrical distributions. Okay, and the mean median value are the very close to each others. These are the some with some judgment about the your normal distributions. Okay, and if it is the standard deviation is very low of your samples, then you will say that it might follow a normal distribution. So gradually after that, you can able to see that you can identify that some test is there to check your data is that normally distributed or not. That, so that you will do with the help of the Shapiro-Wills test is there, which will decide that your data is normally distributed or not. That, so this is the first thing for the parametric methods. Okay, so if it is your data is following that it is a normal distributions, then you will go for the parametric test. Otherwise you need to look other methods that is the available in the non-parametric methods. Okay, second assumption that the if it is you considering the two sample or more than two samples, then their variability, so their variability is close to each other. So we will talk about the standard deviation is very close to the in these two samples, then we can go ahead for the parametric assumptions. Oh, okay, so these are the two important pillars for the parametric methods. So I'm already explained you what do you understand by the parametric method, and we will see that in that case, here in the parametric methods, we will talk about the one sample t-test and two sample t-test and more than two samples, and then you can go ahead with this one. Okay, so this is the now this is the another statistical methods understanding, where you can see that what are these discrete outcomes variable and continuous outcome variables. Okay, so whatever I'm doing the survey, I'm doing the experimental work, I'm collecting some data, and that data is coming the outcome variables. Okay, so whatever your primary variables, primary objectives, which links to the some indicators, and that indicators linking to the your variable. So if those variable are the discrete, then what are the statistics you can use? If it is a continuous, then what are the other statistics is available? So let's we talk about the discrete outcome variable. So discrete outcome variable, so this is the your chi-square test. So the chi-square test is the non-parametric method which is widely used in discrete outcome variables. Okay, so it can be used in the your nominal, ordinal, or discrete data, and then after that you can go for the Fisher exact test, logistic regressions, and the survival analysis. So that you can go for the your discrete outcome variable. So let's say my outcome is that my patient is died or it alive. Okay, so this kind of the judgment can be done with the survival analysis. So this is come into the first part, which is the nominal and ordinal, which you already studies the types of the data. Now we will come on the other side, that is the continuous outcome variable. So continuous outcome variable is the data which having the interval and ratio data. Okay, so if you know that if I will be asking that what is the hemoglobin level of the patients, okay, and what is how much money you spend per day. Okay, as I discussed this example in the very layman term. So in that cases we will be going for the t-test and t-test. Okay, so here we will talk about the one sample t-test and two sample t-test. Okay, so this is the part of the parametric methods. Then we will go for the pair t-test. Pair t-test. So once our sample is dependent. Okay, so for an example, I will be giving more example in the later on part. And analysis of variance, once you will have more than two samples, then you will go for the analysis of variance. If analysis of covariance, it is the part of the dependent variable. So if it is the dependent variable and you capturing the informations of the dependent variable at different time intervals, more than two time intervals, then you will go for the analysis of covariance. Then you will go for the simple and multiple and stepwise linear regressions. Then you will go for the Wilcoxon rank sum test and Wilcoxon sign rank test, and you will go for the correlation. So if you will talk about these two, the Wilcoxon rank sum and sign rank, so these are the non-parametric methods. It's just alternative to your peer t-test, okay, and t-test. So whenever your data is not following these two assumptions, then you will jump on the non-parametric side. So you can go for the non-parametric side. So these are the statistical method which is commonly used. Apart from that, if you will go in depth, you will find the more things in these cases. Okay. So now we will be segregating these two things, that is the parametric and non-parametric methods. Okay. So parametric is already we discussed that if it is my distribution is normally distributed, that is your parametric. Okay, so that is your parametric. If it is your data is skewed and high standard deviations, and it is very huge values with the huge value and low values, in that case we will be going for the non-parametric methods. So we will talk about the x is equals to 2 and y is a normal. So what is the x is equals to 2 means we will have two samples. Okay, so first sample and second sample. So for an example, I would like to see the IQ level of JNU student and DU student. Okay, so this I just want to check. Okay, or I will take an example, another example. If I would like to see the IQ level of JNU student and University of Mumbai student. Okay, then how? So here I am considering the x is equals to 2 and y is my normal. Okay, so if it is, I am saying the my outcome variable is normal, then I will go for the parametric methods. Okay, so if it is your unrelated samples are unrelated, means the if you take the your IQ level of JNU students and IQ level of Mumbai students, so these two are the independent. Okay, so they are not related, so that's why we will saying that these are the unrelated. Related means, let's say I don't know how many participants are here in this workshop. So let's say the participants are came here and I would like to see the IQ level of these students. Okay, so this is the, and usually you are joining this workshop, so we would like to know what is your prior knowledge and what is the after the workshop knowledge. So I think the coordinator told me that you need to send the some questions so that we need to assess the students knowledge. Okay, and then after that we will be looking at how much they got. Okay, so accordingly they will make some more actions. So this is the related sample. So means same subject is there, but some the assessment or the capturing of the data will happen at two places. Okay, or two time intervals. So let's say before of the training and after the training. Okay, so before of the gym, what is the your weight, and after the gym, what is the your weight. Okay, so what is the your temperature, body temperature, and after the taking the medications, what is your temperature. So this is the related samples. Okay, and if it is your y is not normal, okay, it means that this is the this follow. Okay, so I'm talking for the non-parametric. So if it is the x is equals to 2 and y is not normal, then we will be going for the unrelated or related sample. So for the unrelated, we will be going for the Wilcoxon rank sum test, and for the related we will be going for Wilcoxon signing test. Okay, so these two tests we can follow, and we can go ahead with this one. Now we will talk about the x greater than 2. X greater than 2 and y is again normal. Okay, so if we will have more than two samples, so let's say the sample 1, 2 and 3. So I'm considering the University of the Hyderabad, University of the Mumbai, and the University of Jawaharlal Nehru University. So these are the three universities, and I would like to see the what is the IQ level of their students. Okay, so it is conducted at three places. It's JNU, and then Mumbai, and then Hyderabad. Okay, so these are the unrelated samples. So for that, I would like to apply one-way analysis of variance. Okay, second one is the related. So related means again. We will take an example of the you all participants. So what is your prior knowledge of this workshop about the statistical or research methodology? Then we will assess this one, and after the completion of this training, I'm again assessing, and after the 1 week we will be again assessing your knowledge about the this research methodology workshop and the statistical methods. Then we will be going to apply the repeated measure of ANOVA. Okay, so this is called the repeated measure of the ANOVA. So this is in case of the your data is normal. So if it is your data is not normal, then you will definitely go for the non-normal side, which means that your distribution not symmetrical, not follow close to the mean median value. Then we will go for the unrelated, means Kruskal-Wallis test, and related means Friedman test you will be choosing. Okay, so these two things can be done in case of the non-parametric methods. Okay, so this is the same things you can do it here if it is your data is normal, if it is following the assumption, otherwise you need to look the non-parametric method. So this is the basically the understanding about the parametric and non-parametric. So parametric is that you need to follow the assumption of the normality and the equality of the variance, and other sides you will just talk about the non-parametric methods. Okay, so these are the two things which you can understand from here, and we will talk about one by one about these two things. Okay, so is that clear so far? Whatever I discuss here about the structures, how you can understand the parametric method and non-parametric methods. Okay, so this is clear. Now we will come on the t-test. Okay, so you already knowing that are you collecting the one sample, two samples, or maybe a more than two samples. Okay, so this is the very clear. You should know the very clear idea about the what is the one samples, two samples, and then three samples. So initially, in first time I'm doing the study IQ level of the student of the JNU. So it is my independent study. So done by so and so professors. Then another study will done by the two professors, and it conducted in University of Mumbai and the JNU to understand the IQ level of the students. So this is two samples. Okay, so two times we considering the samples. If it conducted at different parts, so let's say we are considering the Chennai, and then we considering the University of Hyderabad, University of Mumbai, and JNU, and to understand the IQ level of the students, then it is the four samples are there. Okay, so now you can understand that we are talk about the what is one sample, two sample, three sample, and the four sample, which we will be using here in that parametric method. So let's we begin with the t-test. So in the t-test, we will talk about the one independent samples. Okay, so if you will have one independent samples, then how you can understand these all things. Okay, so in the one sample, it means that the comparison between the one group of the subject with some hypothetical value. Okay, so you considering the one sample, but the some hypothetical value is already there, which is already mentioned in the some reports, some published work, and somewhere else, or scientists think that that would be some average value. So in that case, we will be going to use the one sample t-test. Okay, and what is the purpose of this one? So it's compare the mean response. So it's compare the mean response from one treatment group to the hypothetical value. So this is the purpose of the t-test. So t-test always look the what is the your average value, what is your mean value, that is the we are finding out from the t-test and the analysis of variance. So so this is the t statistics, and this is you can understand that x bar is nothing but it is the mean value of the your sample one. Okay, and this mu naught is nothing but it is the your hypothetical value, hypothetical mean value, and s by root n. So it's nothing but it is the you need to find out the sample variance, sample standard deviations, and this is the n number of the observation, number of the samples in number of the samples or observation in your sample that you would like to see here in the t-test. Okay, after that you need to decide about the your null hypothesis, is that rejected or it is failed to rejected. So this is about the t-test. So what do you understand by the t-test? This is we trying to do it from the t-test. Now we will so is that one sample t-test is very clear for all of you? Okay, after that we will talk about this is my next slide, that is the normally distributed means you will be going to apply the parametric methods. Okay, so in the t-test we will again talk about the two independent samples. So two independent samples means either you can take your research on the male and females, two different locations, and these should be independent samples. Okay, so comparison between the different group of the subjects. Okay, so what you are doing, you are comparing between the different group of the subject, and what is your purpose? So compare the mean response from the two treatment groups. Okay, so mean response from the two treatment groups. So one is the treatment group, this one, and which we are giving the paracetamol, and we are giving the placebo to other one. So this is the basically the comparison between these two. So that you can understand that this is your two sample t-test. Okay, so two independent sample means you will be going to apply the two sample t-test. Now we will talk about the pair t-test. So it is a one sample with related values. Okay, so we are coming with the one sample, but it with relative values. Okay, so before and after. So before of this workshop, what is your knowledge and how much marks you got in exams, and after of this workshop, what is your knowledge and how much marks you got. So this before and after measurement within the same subjects. Okay, so you all are the same participants, so that's why we are saying that it is the one sample, but it taken data collection happen at two places, before and after. Okay, pre and post. Okay, so this is an example of the pair t-test. So for an example, so blood pressure changed from the baseline within the group. So from any particular points, how it changed from the particular point. So let's say in the morning what was your blood pressure, and in the afternoon what is your blood pressure after taking the medications. Okay, so marks obtained before and after the class taken by the ICT tools. So it is another example which we can understand it is a part of your educational technology. Okay, so in that case you can also understand that what uh, what is the change from the in two different time intervals, what happened, what change is there. So that change is nothing but it is a one sample, and it is called as the pair t-test. Okay, now we will come gradually to understand that how you will do all things in the two sample t-test. Okay, so t-test comparing the mean from one group subject to the hypothetical mean value is compared. Okay, so let's I will be so in always if you will talk about the one sample t-test, two sample t-test, paired, ANOVA. So what we are basically doing that we are understanding that what is your mean value, what is the change in the mean value, is that different with the hypothetical, is that different with the other group, it is the different from the two time intervals. Okay, that's we are doing here in the um, analysis of variance. Okay, so this is the basically, so t is nothing but the mean of your one sample and the mean hypothetical mean value. So we are finding the difference between these two and their variability. Okay, so variability is nothing but the variability you are just finding out from the your one sample, and this is your t statistics, and this is your difference of value, so that you are finding from the one sample t test. Okay? So this is the you can understand the what is the one sample t test. So in the layman you can see that just finding the differences between the mean values. Okay, so one sample or two sample or maybe a more than that, what is your purpose is that you just looking that is there any significant difference between the mean value of the one group to the other group. That's you are doing here in this one. Now we will talk about the t-test comparing the mean from two different group of the subject is compared. So two different group of the subject means one sample is there, other sample is there. Okay, so finding the differences in mean. So mean of one and mean of two and their variability. So this is the s square by n1 and this is the s square by n2. So this will give you the variability in these two samples, and this is called the your t statistics. So is the differences significantly differ from zero when compared to the variability. So that's we are trying to compare. So this is the your two sample t-test. It is also called as the student t-test. Okay, so this is also called as the student t-test. So you can also pronounced as this is the student t-test, or maybe a two sample t-test or independent t-test. Now we will come on the major parts, that is the assumption for the t-test. Okay, so a lot of the assumption is required while you are doing the statistical analysis. It can be done very easily. You can just find out the difference of these two samples and you can solve these problems. But the samples, what are the assumption for the t-test? That is, the samples are independent. So I'm talking for the two sample t-test. So sample are independent, well-shaped distribution like a normal distributions. So independent means you are talking for the IQ level of JNE student and the Mumbai students. Okay, so these two are independent. It's not related to each other. Okay, so bell-shaped distributions. So whatever the data is coming up, so that should be in the bell-shaped like a normal distributions. The bell-shaped curve is center around 0, and the tails are slightly thicker. The thicker the standard normal variant, standard normal bell curve. Okay, so this is the another assumptions. Once we talk about the t-test or two sample t-test, then sample size exceed 30. That means t distribution will be same as the standard normal distributions. Okay, so here in this two sample t-test we will going to use if we will have the smaller samples. Okay, so smaller sample means less than 30 sample or equals to the 30. Okay, so this is the this is your t distributions, and you need to understand this graph very carefully. So what do you understand by this one? So it is the t distributions which follow a normal distributions, as this is was one of the assumption. And here we will say that do not reject h naught. So here you cannot reject h naught, and this is the your critical value. Okay, so this is the critical value, and this is the observed t statistics, and this is the p-value reject h naught. Okay, and this p-value is also, if it is your value is coming out outside of that regions, that means you are rejecting h naught. So if it is value is coming after this, and this is your alpha by 2, and this is your alpha by 2, and this is your p-value. Okay, and this is your t distribution. So if it is your value is coming uh, in this range, then you will not reject it. Okay, so do not reject, that means. So this is the t distribution interpretations graphically how you can understand. So I'm trying to explain you now. When the observed t statistics is so large in the magnitude that fall outside the regions marked by the two critical points. So we mark by the two critical points. These are the two critical points, and we conclude that the observed differences is larger than the expected by chance. Then there is a 5% of the chance that we made a wrong conclusion or wrong decisions. So this is basically 5% means 5% level of significance. So for an example, you can take that marks of the one students, marks of the other students. So this is the one class, this is the other class. So these are the two independent samples. So you can just find out the mean value and the variances, variability, and you can just go to with the t value. So t value is whatever is your t value. So this is your t value, where from where you can just see that is that um, it is a calculated t value and your tabulated t value. You can compare this one, or you can go for the p values. Okay, so this you can go for the p value, and then you can make the decision. So this is just idea about that what you will do in a t-test. Okay, two sample t-test. If you would like to do this analysis with the help of the SPSS, then you can go for the compare mean. Okay, so compare means you can go for the analyze, and then you can go for the compare means, and it will show you the one sample t-test, two sample t-test, or pair t-test, and one way ANOVA. And accordingly you can just see that what is your data, what is your objective, then accordingly you can get the answer of your questions, and you can say that your hypothesis is rejected or not rejected, so that you can do with the help of these all results. Okay, now we will talk about the next one is the uh, pair t-test. Okay, so pair t-test means you will be having the two samples before and after. Okay, so before of the taking the medication and after of the taking the medication, what is the change in your blood pressure? Okay, usually it is understand that if you will go for the regular walk, then your blood pressure going to be down. Okay, so that you want to check it. Okay, so you can just take that your blood pressures before of the going for a walk, and after the coming back to the from the walk, you can just see that is there any difference between the mean value of these samples, or they are same, so that you can do with the help of this t-test. Okay, so this is the your assumptions, and you can just find out the difference means the pre minus post, or post minus pre, that whatever you want you can just find out, and find out the variability between the your different samples. So this is your paired t-test that you can find out. Now we will talk about the analysis of variance. It is the next part of this course. That means we talk about the one samples, two samples, if they are independent or if they are paired. Okay, so we will already know that how to compare the mean value in that cases. If it is your sample is more than two sample group is there, so sample group number 1 is there, 2 is there, and 3 is there. For an example, JNU, then University of Mumbai, University of the Hyderabad, and you would like to see the IQ level of these three students. In that cases, you need to you will be going for analysis of variance. Okay, so this is the slide for analysis of variance. So when we want to make a statistical inference about set of mean from more than two treatment group. Okay, so if it is you want to go for more than two treatment groups, although more than two treatment means are compared, the procedure is called analysis of variance. Okay, so this basically the treatment mean value are compared. That procedure is called the analysis of variance, and the total variability in the data are partitioned to test the total variability. Okay, so we will just partition to the test the differences among the means we doing. So this is called the one-way analysis of variance. So this is the one-way ANOVA, and in this case we will be using the F test. It's follow the F test, and basically what we are doing, we compare the sample variability between the groups with samples variability within the groups. That's we are comparing, and the test statistics, earlier we used the T, but here we use the F, and again the formula would be same. So differences in the means and the variability of the differences, and this is nothing but F statistic. Okay, so basically what is here we trying to understand that if we will show through this graph, so this is your mean response value. Okay, so this is the mean value, and this is for, let's say, for placebo or 0 mg dose is given to the patients, 10 mg dose is given to the patient, or 30 mg dose is given to the patients, and then we would like to see that how this value is going to be the closer to the mean value. So basically whatever the variability, so if you will see these red red symbols. So these are the far away from the mean value. So how we can reduce these variability, so that we will doing with the help of the analysis of the variance. Okay, so this is the my model. So we will be following that yij is equals to mu I plus epsilon ij. Okay, so mu I is nothing but the mean value of the sample 1, mean value of sample 2, and mean value of sample k. Okay, so whatever the sample is there, and yij is the response for the jth subject from the ith treatment group. So this is the nothing but it is the your outcome variable, and this is the your random error associated with the j subject and the ith treatments. So model assumption often referred to as a parametric assumptions. Okay, so it's follow the error are independent. These errors should be independent, and these error are normally distributed with mean 0 and equal variance sigma square for each group. Okay, so this is my assumption that it's normally distributed with mean 0 and the equal variance sigma square for each groups. Okay, so this is your assumption for parametric methods. Okay, so this is the assumption you need to follow. Apart from the two assumptions we already discussed, that the normality of the data and the equal variance of these samples. So how you can understand these two, or how you can make the hypothesis. Okay, so let's we talk about this manner. Okay, so always either you will do in one sample t-test, two sample t-test, or paired, you always write the null hypothesis. So in case of the analysis of variance in ANOVA, where we will have the more than two samples, then we will write all mu i's are equal. And in alternative hypothesis, what we are writing, that at least one mu I is differ from the others. Okay, so what is the meaning of all mu i's are equal? So let's say the mean value of JNU IQ level, Mumbai IQ level, and the Hyderabad IQ level are the same. In these three samples, these are the same mean value, and in alternative hypothesis, here we will be writing at least one is differ. Either Mumbai is differ with the Hyderabad, or Mumbai is differ with the JNU, or JNU differ with the Hyderabad. At least one is differ, so that will happen. That is your alternative hypothesis. Okay, so using the test statistics F, and it follow the F distribution, we can obtain the p value, and the probability of the observing the test statistics extremely as an observed value by chance alone, and how you can make the decisions. Okay, so it's very good questions wherever you will do that analysis with the help of the SPSS or with the help of the any R software. So you can talk about that. The p value is less than 0.05. So this is the less than 0.05, then reject H naught. So you will say that at least one mean value is different with the others. So if p value is greater than 0.05, that means fail to reject, means you just needs to reject the your null hypothesis. Okay, so this you will do with the help of the analysis of the variance. Okay, so this is a very important part for all the cases. Okay, so all the cases means if we will talk about the one sample, two sample, or pair samples, that is you need to follow this one. Okay, now next part, if you will go in deeper this one analysis of one way ANOVA, then when the overall F test is significant, we are interested to know that which treatments means are the different. So either the mean IQ of JNU is differ with the Mumbai, or mean IQ level of JNU is differ with the University of Hyderabad, or Hyderabad too. So we need to find out the which one is differ. So that is called the your post hoc analysis. Okay, so post hoc analysis, that you trying to find out if you got that your null hypothesis is rejected. So multiple comparison procedures are used to answer such questions, so that you can explore different methods is available to go for the postdoc analysis. When pre-planned comparison are to be made, we use the contrast estimates, contrast and estimate statement in the analysis. Okay. So this is the another example where we will talk about the ICT flavor is for the class the flavor 1, 2 and 3, and these are the changes in the marks. Okay, so whatever the changes you will see, or whatever marks you will assessing from these two flavors of the ICT, and then you will going to apply the this analysis of variance. So this is your F value, which is the 2.515, and P value is the 0.09, and after that you can easily make the decision. So whatever you want to make your decisions, that you can do it over here. Okay, so this is the one way analysis of variance. Okay, now how we can understand in a layman about the model assumptions. Okay. So if these are the model assumptions, so if you will see that is this the green and the red graph is normal distributions, definitely it is not normal distribution. So if you will see that the mean value is scatter on the right tail. Okay, so and in the green also the most of the value cater into the right side, so it is not a normal distribution. So this is not a normal distribution, but you can see that the figure 2 where we can see that it is a normal distribution because it's just following a symmetrical curve. So if you will cut from here, then this value are the equally symmetrical. Okay, so this is the symmetrical distribution, but it is unequal variances. So the variability between these samples is very less. The variability in this samples in the blue, it's very high. Okay, so this is not a unequal variance. So this is the one assumption is fulfilled here and other is not fulfilled in these questions. So we will say that this is the your normal distribution but unequal variance. So how it will look like the both the cases, the normal distribution and equal variances. So you can see that in the mu1 and mu2, so mean of one sample, mean of the other samples. So this is the variability of this graph, and this graph is almost same. So in that case you can say that it is a symmetrical and the most of the value is lying into close to each others, and this is the normal distribution and the equal variances. Okay, so this is the another assumption, or this is the primary assumption for the test as well as for the analysis of the variance. So equality of the variance, it is understand that equality of the variance is the most important assumption for in ANOVA. If the variance are not equal, then the statistics are not valid. Okay, so whatever you are predicting, whatever you are reporting in your papers, in thesis, that is a wrong. If it is, we are not looking of these assumptions. Obtain these standardized residuals. Recall that standardized residuals follow a standard normal distributions. So check the 68% of the standardized residual between the -1 and 1, 95% of them should between the -2 to 2, and all of them should be -3 to 3. If it is this, then you will say that the residuals are the standardized. So plot these standard residuals for each treatment group to see if the funnels with the funnel shape that you can do. If the plots of the residuals show some concern, then you transform on the data. If the transform does not take care of your problem, then residuals of the model based on the transform data does not seem acceptable, then you can go for the non-parametric one-way analysis of variance. So far we here talk about the what we can do in parametric methods. So we discuss about the one sample t-test, two sample t-test, and paired and analysis of variance. And after that, you can see that a non-parametric methods will come up if it is these assumption is not fulfilled. Okay, so if it is these assumption is um, not showing by your data, then definitely you will go for the non-parametric methods. Okay, so let me show you some extend to this one. So decision rules for parametric versus non-parametric, how you can make the decision, either you will go for the parametric or you will go for the non-parametric. So if one or both of the parametric assumptions, okay, so one or both parametric assumption are normality and the equal variances is violated, then a non-parametric test for equality of the treatment means is more appropriate. Okay, so if it is these assumption is violated, then you can go for the non-parametric methods. Simulation test suggests that the parametric ANOVA is fairly robust against the departure of the normality. Okay, but not unequal variances. Okay, so if it is, you will have the not normal in some cases because it's just came from the simulation. So you did you just increasing your samples and then you will trying to predict this one. So this is the happen, but it is always suggested you will go for whatever the assumption is with you. In general, the parametric ANOVA is preferred test in the most of the cases when the data is continuous and the sample size are small. So, okay, so in that cases you can go for the analysis of the variance. So just I'm also highlighting you on what you are doing in the non-parametric test. So basically it is the rank based. Earlier what you are looking in the parametric methods, you just looking the uh, you are just focusing on the mean value. So here earlier you are just comparing the mean value, and that is the your primary point where you deciding about that what you want to do. Here in the non-parametric, you just go for the ranks. Okay, you just put your data in ascending descending order and take out the ranks. So this you will do in the non-parametric method. So instead of the mean, non-parametric test is compared with the distributions. Intuitively, non-parametric method compare the centers, medians of the two samples. So that is the replaced with their ranks. Okay. This is the Kruskal-Wallis test is non-parametric overall test. So it is the analogous to one-way ANOVA Kruskal-Wallis test. Rank all the data, give rank 1 to the smallest value without regard to which treatment group they are in, and calculate the sum of the ranks from the each of the K groups. Compare each treatment average ranks to the overall mean value. So that you will do in a Kruskal-Wallis test, and this is the formula for the Kruskal-Wallis test. You can just get it from the anywhere, and it's calculate the statistics and compare the results with the value of the chi-square distributions and large chi-square mean value that do not support the null hypothesis. Okay, so if it is a larger value of the chi-square, it's saying that you rejecting the H naught. Overall test for the Kruskal-Wallis and non-parametric. So test strategy based on the approximate chi-square distributions, does not use the assumption about the distribution of the data, more robust for the outlier. So if it is any outlier in your data, skewed data is with you, then you can go for this one, a non-parametric method of Kruskal-Wallis, and does not use the all information in the data. So it is the less powerful than the parametric ANOVA. So moderate analysis can be usually done in these cases. Okay, so if it is, this is the your parametric versus non-parametric. So if you will go for the t-test for the two independent samples, so then you can go for the Wilcoxon rank sum, then Pearson, you will go for sign rank test, and analysis of variance is you will go for the Kruskal-Wallis test. So, or if ANCOVA, then you will go for the Friedman test. Okay, so these are the things which you can take away from here, and now it's you can just now tell me if it is you will have any questions on the parametric methods, and then we will discuss for a while uh, about your problems and the questions on the parametric methods.
Any questions from the participants? I think, sir, they are very much clear with whatever that you have shared so far.
Okay. So I think no one is asking any questions. So if you have any questions, links to this parametric method or any research methodology questions or statistics, that even you can ask over here.
Sir, I think we can continue further.
Okay. So dear participant, I am sharing these questions for all of you. Can you tell me which statistics you are applying for this case? So now you can raise your hands or you can just speak. What test you can apply in this question? Um, can you, ma'am, open this chat to everyone?
I'll try, sir. There was some technical error because I can see the chats, but participants are not able to write it there. I'll
Yeah,
just
even
still
I
try
can,
to see that.
yeah, yeah. And even participant, you can speak on this question.
I think Kavita had raised her hand.
Yeah, Kavita, please.
Yeah, it's one sample t-test.
One sample and
T-test.
okay. What are the others saying? So in this questions, you can directly go read these questions. A random sample of 10 athletes in a college had a IQ scores is 75, 115, 110, 102 like this. So 10 observations are there. Do these data support the assumption of the population mean IQ of 105 at 1% level? So this you can make the decisions. Okay. So this is nothing but it is the H naught is your null hypothesis that mu is equals to 105 and H1, this is your H1, which is the mu not equals to 105. So T is x bar minus of mu s by root n. Okay. And this is your calculated T. So once you will put this data into your SPSS or you do a calculation yourself, then you will get this T value is the 1.96 through this formula. This is the s by root n. Okay. And this is your tabulated value. If you will look the T tabulated value, then you can make the decisions. So this is the, since the observed T value is less than the tabulated T value, so accept H naught at 1% level of significance. And if you are doing this exercise in SPSS, then you will get the this kind of the output. And here from here you can see that this is your T value and this is the your P value, and you can make the decisions. Okay. So based on this P value you can make the decision. So it is greater than 0.05, and then you can easily do that. It is rejecting the H, it is the accepting H naught. Okay. So this you can see it from the both the way, from the SPSS output as well as from your manually outcome. Okay. So this is the one sample T test. Now we will going for the next step, that is the, this is the question is in front of you. Now you can read it and tell me what test you can going to use for this one. So what test you can use for this one? I think madam you can unmute all of them. They wants to speak, they can speak.
Yeah, they can unmute on their own. Everyone is given the rights now.
So here there are the two cases, that is the vertical jumps performance of volleyballer and basketballer in the centimeters. The test, we are testing that the group differs significantly in relation to the performance on the vertical jumps. So this is the one sample data, this is the other sample data. So both are the independent. Okay, so we can write the hypothesis. So mu naught is mu x is equals to mu y, mu x is not equals to mu y, and this t is at your difference of the mean value of the sample 1 and sample 2, and you are just finding out the variability. And here this is the n1 plus n2 minus 2 is your degree of freedom. Okay, so in the earlier case, what was the degree of freedom? N1 n minus 1. Here n1 plus n2 minus 2 is your degree of freedom, and you can just find out the this is the tabulated value. And if you would do it this in SPSS, so you will see that this is the mean value and this is your standard deviations. And here you can go for the t-test. This is your degree of freedom is 80 and significance level is this one. Okay, so you can just say that what is your interpretation about this this case. So you can predict this thing and you can write the inference as well. Okay, so next case is the data is in front of you and you can read these questions and understand where we can use the pair t-test.
Yeah, participants, you are allowed to unmute yourself.
So here we'll use paired t-test because it is before and after data.
Okay, any other one? So from this example, you can clearly see that some aerobic workout is given to the uh, some patients, and then we seeing that what is the change in the hemoglobin level. Okay, so you can see that this is the pre and post data. You can find out the D difference. So Y minus X. So this is your now samples. So this is your sample 1, but the assessment can be done in pre and post. Okay, and this is your sample. So D is your sample. So Y minus X, and this is your null hypothesis and alternative hypothesis. So you can find out summation D square. Then you can just find out that this is the formula for T is equals to d bar by S by root n, and this one. So you can just see that this is the your test statistics, and here degree of freedom is n minus 1. So you can see this is the your mean and standard deviations, and this is your p-value. Okay, so based on this p-value, now you can make the decision about the your analysis. Okay, so you can see that is this p-value is less than 0.05 or greater than, and accordingly you can make the decisions. So here h naught may be rejected at 5.5, level of significance. Thus, it may be concluded that aerobic workout increase hemoglobin content. Okay, so this is the your interpretation for this case. Now you can see the next example. So you can see this problem and then you can tell me which tests you can apply here. So here you need to verify the hypothesis. Study was planned by dividing 30 students into the 3 groups of 10 each. Then students were assigned to these 3 groups in a random fashion and all of them are compensated to the read for the 20 minutes. Okay, so this is the basically to assess that what is the change if we will provide the melodious music, orchestra and without music, and what is the impact on their scores. Okay, so in that case you can go for the analysis of variance, and this is the descriptive statistics for analysis of variance. This is the ANOVA and this is your F value. You can do the multiple comparison. Okay, so this way you can see that how you can apply the t-test in a different cases. So this is I think this is my my last presentations which for all of you. So if you have still any questions, then you can ask me. So participant, if you have anything you want to discuss, so please let me know.
Sir, this is Kavita here. If you can explain more about the NOVA and NCOVA.
Sorry?
Between NOVA and NCOVA, can you a little bit give us more detail on the same?
So ANCOVA or ANOVA is already discussed. So ANOVA is what? Once we talk about the if we will have more than 2 samples and your data is independent, samples are independent, then you can go for analysis of variance. If it is your data is dependent, means you will considering at 3 different time interval, 4 different time intervals, but the same subject is there, then you can go for the analysis of covariance. So anything you want to ask?
Yes, Kavita, you can. You wanted to ask something?
Sorry, I did already. Thank you.
Okay, so participants, the platform is open for discussion. If you have any questions to be asked related to your research or the area that you're working upon.
Sir, this is Professor Kavita Patil. Can we use more than one test in our sampling or analysis?
One test means it's depend
So
on the
like,
your data and the objective. You can go ahead, but it's
mhm.
depend on the your objective. So if it is your objective is that if you want to compare the mean value of two samples, then you have to go for the only the independent t-test. So it is strictly depend on the whatever is your objective.
Okay.
Any more questions to be asked? I think, sir, we are well versed with it. I think they had understood very clearly with the help of the examples that you have given, sir. So I take this opportunity to thank you and for sharing your knowledge, experience, and expertise in the field of statistics. And every time review of literature objectives, at least it becomes very easy due to we read it a lot of theoretical the data and then we are able to write it, but statistics is somewhere where really we need to have some expert to talk on, and you have really done justice to the session by sharing your expertise and examples that you have given. So thank you so very much from the bottom of our heart, sir. Thank you.
Thank you. Thank you.
Participants, just a reminder, tomorrow we will be having a session on non-parametric test, and ma'am has already requested you to download the MyStatics, Megastats, the software in the Excel. So I'll advise you if you all can be ready with it beforehand, so that once when ma'am is guiding us, we can also have hands-on practices or on your end. So request you to download that app today itself so that tomorrow it becomes very easy for us to use it. The feedback link for today's session will also be sent to you in your WhatsApp group. Kindly fill it up and that's it. Okay. So see you all tomorrow to have more on non-parametric test. Thank you so much.